Welcome to this course on combining data in pandas using concat and merge. If you're working in data analysis, you'll often have to combine two data frames together. Maybe you have two CSV files that you want to combine, or some other types of data that you're pulling from an API, but you want to combine them in order to gain some interesting insights. Now, how do you perform these operations using pandas? And what's the right function to use? Should you use pd.concat or should you use pd.merge? Do you want to concatenate data frames, or do you want to use database join operations? And what does all of this really mean? And finally, what's this tomato got to do with all of that? In this course, you'll set up a working environment and create a quick dataset, and then you will learn about how to use pd.concat and pd.merge to combine your data using pandas. You'll start by creating a virtual environment and installing the necessary dependencies. Then you will create a healthy data set that consists of just two small data frames that you will work with throughout this whole course. You will get to know the pd.concat function in depth, and you will get to know a lot of the optional keyword arguments that you can pass to this function. On this slide, you can see all the keyword arguments that you will work with throughout the course. You will start by concatenating two data frames along the row axis. Then you will concatenate the same data frames along the columns axis, and notice how the results are quite different. You will learn to mark your data frames using keys to create a multi-index data frame. Then you'll see how you can access data in such a multi-index data frame. Alternatively, you'll learn how you can recreate a new index after concatenation. And then you will start going into database join territory when you learn how to join the columns while concatenating on rows, as well as how to join the rows when you're concatenating on columns. Next, you will get to know the merge function in pandas. Again, you can see that there's a lot of keyword arguments that you will learn about throughout this course. You will start by performing an inner join, continue with an outer join, and then explore other joins that you can do, specifically left outer and right outer joins. In another lesson, you will learn how you can specify the join columns explicitly using the on keyword argument, and how you can join data frames using index columns or named columns from either of the two data frames, or even combinations of both of those. You will perform a cross join to create a Cartesian product of both of the data frames, and you will learn how you can customize the column suffixes so that you can still keep an overview of where did the data come from. Finally, you'll get to practice your intuition about using database joins with pd.merge and run into a couple of peculiarities and gotchas that are helpful to be aware of. And that sums up the content of this course. I hope you're excited to get started and that it will be useful for you to practice the skills of combining data using pandas. In the next lesson, you'll get started getting started. You are now in the first section of this course where you'll get started with a couple of video lessons that'll show you how to set up Jupyter notebooks, and then also how to create and explore the example dataset, which will have something to do with tomatoes. To set up your environment, you'll first create a virtual environment, activate it, and then install a couple of packages before starting a Jupyter notebook. I will show you how to do this in a Bash console, and these are the relevant commands. If you're on a Windows machine, the commands will be slightly different, but the process will be the same. So if you're on Windows, just pause, take a screenshot of this, or come back to this slide and punch in the relevant commands, and you'll be set up in no time. Let's get started. To get set up, you should first create a new folder for your project. Move in there, and then create a virtual environment. You then activate this environment. And once you can see that it's successfully been activated by the prepended prompt of your virtual environment's name, then you can install pandas and Jupyter into this environment. These are the only two dependencies that you will need. And we can skip to the end of this install. Once everything has been installed, you can go ahead and start the Jupyter Notebook by typing Jupyter Notebook. This will open up a browser window for you. And in there, you can start a new notebook. Your browser should open up with a window that looks similar to this one. You see you have your virtual environment folder in there, and so far nothing else. So go ahead and create a new notebook by going to the New dropdown and selecting Python 3 IPyKernel. And if you see this screen, you're ready to get going. Here's another quick view of the commands that you used, first for Linux and macOS. And then here's the commands on a Windows machine. And that wraps up setting up your Jupyter Notebook environment. And in the next lesson, you will create and explore the example dataset. In this lesson, you'll get to know the example dataset. And you will see it's a very healthy example dataset because it'll consist of fruits and vegetables. And the dataset is really going to be quite small, and it will consist of two data frames. The first one is going to be sourced by your orchard. So this is going to be a couple of fruits and their respective emoji images. And the second one is going to be some vegetables sourced from your garden. And you might already see that this will nicely load into data frames the way that I created it here. And you have this name and image, and then a couple of rows for each of those. Not great drawing, but you can see where I'm going with this. And I'll let pandas do the drawing because it's actually a little better at it than I am. So let's go ahead and load this into pandas. For that, I'm going to first have to import pandas. And I will use the common PD shortcut to then work with it. And then in here, I'll just create two data frames. The first one I'm calling fruits. I pass in the orchard. And then do the same again for the garden. But call that data frame veggies. And here we are. So I've loaded these two lists of dictionaries into data frames. And now I can go ahead and let pandas draw the tables for me. We can see the fruits data frame consists of two columns. One is name, the other one is image, and then it has an index column as well. And here you have the name of the fruit and then the emoji image. And then the same or similar thing for the vegetables as well. You have a name and an image column, but then you also have this additional colors column. And you will notice that the fruits data frame has one additional row. So it's got 4 rows, and the veggies data frame has only 3 rows. And this small differences between them so that there's an additional column in one that the other one doesn't have. And also, as you might notice, there's a tomato in both of them. So we'll use these features of these data frames to try to visually exemplify what the merge and concatenation operations do in pandas, respectively. And that's really all to say about this data frame, except maybe if you're wondering, tomatoes are fruits, but they're also generally used as vegetables. So this is kind of the funny little joke that I'm doing here to use as an example. But I think it's really going to help in showing how this merge and concat works in pandas. Here's another view of the code you used to generate the dataset. And that wraps up the first section that was about getting started. In the next section, you'll begin to combine data using pd.concat. And specifically, you'll begin with concatenating two data frames along the row axis. In this lesson, you'll learn about the module level function .concat in the pandas library that you can use to concatenate data frames together. Before I will actually run this here in the lesson, I'm going to give you a blank screen and draw it out a bit. So remember, we have these two data frames that we're working with here. And one is basically the fruits that consists of 2 columns. And then it has 4 rows. And then the second one is your vegetables. And that has a different shape. It's got 3 rows and it's got 3 columns. So it looks kind of like this. If you would just stick those two things together, there's this empty space that appears up here. And this is literally what pandas does when you concatenate these two data frames. It just needs to fill this space with something as well. What pandas puts in here are NaN values, which stands for not a number. And this is your resulting data frame, essentially. Let's look at that when you're actually using pd.concat on these two example data frames. We're going to say pd.concat, and then for the function call, I need to pass a list, an iterable of two data frames, for example. So I can put in here fruits and veggies. And when I run this concatenation, then you can see that you got exactly what we were expecting. You still have your fruits data frame here, consists of 2 columns and 4 rows. And you have your vegetable data frame down here, just stuck below it, 3 columns and 3 rows. And just like in the schematic that I showed before, over here, you have this empty space that pandas needed to fill with something. And what it puts in here are NaN values. So this gives you a quick overview of what pd.concat does without passing any other arguments. You're just putting in these 2 data frames and you're getting your result down here. Now, the order matters. What do you think is going to happen when you do the same thing but pass veggies before you pass fruits? You can pause for a second and try it out yourself. But probably your intuition is going to be right about this. You get the same result, but in a different order. So now you can see you have the vegetable data frame up top, and then you have down here the fruits data frame. And what is maybe a little bit surprising is the order where the NaN values go. But that's just because you have this specific order of the first data frame that gets preserved. And the vegetable data frame was first column name, second color, third image. So this needs to be applied on the one that gets concatenated to it. And because the fruits data frame didn't have a color, it gets filled up here with NaN values. The information that you get after this concatenation is the same, but the order of items is going to be different depending on how you pass them in here to the function. This shows you the plain, no arguments version of running pd.concat on 2 data frames. In the next lesson, you'll explore some of the arguments that you can pass to change the behavior. In this lesson, you'll start taking a look at the optional arguments that you can pass to pd.concat to change the way that it behaves. One thing that I like to do when working with a new function and exploring it is to look at the documentation. And in IPython notebooks or just the IPython interpreter, you can do this by passing a question mark at the end of a function instead of actually calling it. And that brings up the documentation right in here in the notebooks or in your console if you're running the IPython console. And you can also open it up on the website, on the pandas website, but this will do for us right now. So here you get the function signature, and you can see that pd.concat takes as the first argument an iterable, which is what you did up here by passing a list of 2 data frames, vegetables and fruits. And then the second argument that we're going to take a look at now is axis. And this defaults to 0, which stands for rows. So what that means is just that it is going to stick the second data frame at the bottom of the first one, so to say. And you can change that behavior. So instead of doing the default, you can say pd.concat, pass in the iterable, and I'll start with fruits again, fruits and veggies. And then instead of just taking the default, axis equals 0, that's the default, or rows, which is equivalent, I will say I want to concatenate on the columns. Again, you could say axis equals 1, which stands for columns, but just actually writing the term is, in my opinion, much more descriptive. So I always like to do that. Now, before you run this, take a moment and think about what's going to happen. You have the fruits data frame, you have the veggies data frame, and you're concatenating them together at the columns axis. And let's draw that out just to take a look. So you're starting off again with the fruits data frame. 2 columns, 3 rows. And then you want to concatenate the vegetables data frame, which is 3 by 3. And this time you don't want to use the default of concatenating it on the row axis, which would be down below the fruits data frame. But here you want to concatenate it by the columns. So it'll look like that. And that's why we draw the columns in here. You have this columns here, and these are the cells. Looks like I'm going to draw all the lines after all. There you go. And again, you end up with some space that pandas needs to fill down here, a couple of cells. And again, pandas is going to input here the NaN values. So this is always just a question of how can you make a complete shape for the table when you just concatenate like that. And pandas does that by filling the empty spaces with NaN values. Now I press Shift Enter to execute this cell. And you can see that the result is as expected. Start off again, highlighting this. Here you have your fruits data frame. Here you have your vegetables data frame. And just like again on the whiteboard, what we saw down here, you have the NaN values that pandas fills. So that's how concatenation across the columns axis works. Now, if you would turn it around again, feel free to experiment with this. It's going to take the order into account. So if you have veggies first, it's going to put the veggies column first, and the NaN values are going to be in a different spot. But you might be confused about all those same named columns here now. Now you have name, image, name, color, image. So the same exact names for the columns appear more than once. And you might not have noticed this before, but actually the same thing happened also up here. Only that it wasn't going across the columns, but across the rows. So here you have the row index, which starts off with 0, 1, and 2 for the vegetable data frame, and then starts again at 0, 1, 2, 3 for the fruits data frame. So there's just a lot of repetition here. And if you would want to pick out one of those rows, for example, by using the location indexer, and you wanted to go by label, you couldn't do that because these labels aren't unique. You have 2 times 0 in here. Or here, if you wanted to address a specific column, you couldn't do this because you have multiple columns with the same name. In this lesson, you learned how to concatenate 2 data frames along the column axis. And you also heard about a couple of problems that you might run into, but you will learn more about them later on. To make this happen, use the pd.concat call, passing in your iterable of 2 data frames, and then also adding the optional keyword argument axis with the value of columns. Now, using columns instead of the default of rows allowed you to concatenate the 2 data frames along the column axis. You also visually saw what the different results are that happen when you concatenate along the columns instead of the rows. In the next lesson, you will learn how you can mark your data frame using another argument, the keys argument, which allows you to create a multi-index, which mitigates some of the problems that can come from having duplicate labels. In this lesson, you look at the optional keys argument to pd.concat that can help you to deal with a situation where you have multiple things named the same as a result from a concatenation, whether that goes by the column axis or by the row axis. Now, before I apply this, let's take another look at the function signature. And you can see in here, there's the keys argument that you'll use. And there's even an explanation in the docstring that relates to the keys argument, where it says it can also add a layer of hierarchical indexing on the concatenation axis, which may be useful if the labels are the same or overlapping on the past axis number. Let's look at that practically by just redoing this exact concatenation. But instead of not passing the keys argument, you will add it here. And you'll say keys equals. The first one that you're passing in is the fruits data frame. So let's just call it fruits. And the second one is the veggies data frame. So you're just giving the names of the data frames. And now when you execute this call, you get a better visual understanding of what do the different columns relate to. So as you can see, it correctly shows you that this part belongs to the fruits data frame. And this part, well, actually not this part down here, but this part is the veggies data frame. However, still, because the third row is missing in the veggies data frame, this is essentially sorted under the columns of the veggies data frame. Now, if you turn this around and use the same call, but instead of using axis columns, you use the default of rows, but I'll put it in explicitly. You could also just skip this whole argument. Then you get the same concatenation that you got at the beginning. And again, you'll see that you have down here, this relates to your veggies data frame. Now there's no NaN part of this one, but you can see that it's part of up there because fruits has one less column. This is the fruits data frame, and then here are the NaN values that it needs to fill to create a full table down here. So this is how you can use the keys argument to pd.concat to give a better idea of where did the data come from and kind of get rid of this ambiguity of having multiple zero indices, for example, or multiple columns of the same name. In this lesson, you've used the optional keys argument to pd.concat to mark your data frames and avoid collisions that come from duplicate label values after concatenation. And you did that using pd.concat and then passing in the keys parameter with an iterable, and often you would just put in the names of the data frames that you were actually concatenating. And this constructs a multi-index data frame that you can then also use to access specific parts of the data frame despite duplicate labels. In the next lesson, you will learn how you can actually access specific data items in such a multi-index data frame, which means that you will take a quick break from the different arguments to pd.concat, stick with the keys one, and then just figure out what are the advantages of actually using this and which errors would you run into if you don't.